Hi students, welcome to physics class. Today we are going to discuss some important concepts. Now at first question. Show that in the absence of any external force the velocity of center of mass remains constant. This is the question. Once again, my dear students, I am repeating the question. Show that in the absence of any external force, the velocity of center of mass remains constant. Now go for solution. Take x-axis, take y-axis, take a point P1, take another point P2. Now this is origin O. The position vector is R1. The mass of this particle is M1. Now take point P2. The position vector is R2. The mass of the body or particle is M2. Consider this is a whole system. Its whole mass is capital M. Now I apply a force on it, that is F external. Now I applied a force on it, that is F external. Suppose an external force acts on a system of mass capital M and produces an acceleration A cm. Once again I am repeating this point. Suppose an external force acts on a system of mass capital M and produces an acceleration ACM. Therefore, F external is equal to M into acceleration center of mass. Consider this is equation number 1. Now, but F external is equal 0. This is given in the question. Therefore, M into A CM is equal to 0. But M not equal to 0. Therefore, ACM is equal to 0. Therefore, ACM is equal to 0. What is ACM? Differentiation of velocity Cm by dt is equal to 0. Therefore, dVcm is equal to 0. If dVm is 0 means dVcm is constant. Is constant. So what is the meaning for that one? Note. dV by dt is equal to 0. The meaning is dV is equal to 0. dV is equal to 0 means that implies V2 minus V1. dV means final velocity minus initial velocity is equal to 0. The meaning is V2 minus V1 is equal to 0. That means V1 is equal to V2. That implies V1 is equal to V2 is equal to V3 is equal to and so on is equal to Vn. That implies V is constant. This is called V. That is V is constant. This is the meaning. This is important point. Now go for question number 2. Now question. Show that the total linear momentum of a system of a system of particles is conserved is conserved in the absence of any external force. Once again I am repeating, show that the total linear momentum of a system of particles is conserved in the absence of any external force. This is the question. Now take solution. Take x-axis, take z-axis, this is origin O. Now take y-axis, which is perpendicular to x and z. Now take 3 points P1. The position vector is R1. Take point P2. The position vector is R2. And so on. Take Pn point. The position vector is Rn. Here the mass is m1 of the particle. Here the mass is m2 and so on. Here the mass is mn. Now the acceleration of this particle is a1. Here the acceleration of particle is a2 and so on. Here the acceleration of particle is an. Now consider this is a system. This is a system. Here the whole mass is capital M. Its linear momentum is P, where P is linear momentum. I applied a force here. That force is F external on the system. I applied a force. That force is F external on the system. Now go for a brief elaboration. Now consider a system of n particles. Consider system of n particles of masses m1, m2 and so on mn. Now suppose the forces are F1, F2 and so on Fn. Exerted forces on m1, m2 and so on mn. produces acceleration. Produces acceleration. A1, comma, A2, comma, and so on, AN. Once again I am repeating. Consider a system of n particles of masses m1, comma, m2, comma, and so on, mn. Suppose the forces are F1, comma, F2, comma, and so on, Fn. Exerted forces on M1, comma, M2, comma, and so on, Mn produces acceleration A1, comma, A2, comma, and so on, An. That means F external is equal to F1 plus F2 plus and so on plus Fn. Consider equation number 1. But F external is equal to 0. This is given in the question. Therefore, F1 plus F2 plus and so on plus Fn is equal to 0. From Newton's third law, M1 A1 plus M2 A2 plus and so on plus Mn An is equal to 0 because F is equal to Ma. Therefore, F1 is equal to M1 A1. Therefore, M1 dV1 by dt plus M2 dV2 by dt plus and so on plus Mn dVn whole by dt is equal to 0 because acceleration is equal to the rate of change of velocity. But here A1 is equal to dV1 by dt. Now take d by dt common. Therefore, we got M1 V1 plus M2 V2 plus and so on plus Mn Vn is equal to 0. But linear momentum P is equal to mv. Therefore, d by dt of here m1 v1 means obviously p1 plus m2 v2 means p2 plus and so on plus pn is equal to 0. here but P1 plus P2 plus and so on plus Pn is equal to the P of whole system. Therefore, d by dt of P is equal to 0. Therefore, dP by dt is equal to 0. Therefore, dP is equal to 0. That means P is equal to constant. Now, note, observe carefully, dP by dt is equal to 0 means that dP is equal to 0. What is dP? Final linear momentum minus initial linear momentum is equal to 0. That means P1 is equal to P2. Therefore, P1 is equal to P2 is equal to P3 is equal to and so on Pn is equal to P. That means P is equal to constant. This is the meaning for that one. Now, question. Show that the total linear momentum of the system is equal to the product of the mass of the system and the velocity of its center of mass. Once again, I am repeating the question. Show that the total linear momentum of the system is equal to the product of the mass of the system and the velocity of its center of mass. Now go for solution. Here we have to prove that P is equal to capital M into VCM. Now take first solution. Take x-axis, take z-axis, this is O, this is y-axis which is perpendicular to x and z. Now take a point P1, its mass is M1. Take another mass of the particle M2. Here P2 is linear momentum of second particle. Take another particle and so on. Mn, its linear momentum is P, its velocity is V1. Here its velocity is V2, its velocity is V1. Therefore, its linear momentum is P2. Here its linear momentum is Pn. Here the linear momentum is M1 V1 is equal to P1. The position vector is R1. The position vector is R2. Here the position vector is Rn. Now take, it is a system. It is a system. Consider its mass is capital M. Now go for elaboration. The position vector the position vector of the center of mass the position vector of center of mass of n particles, n particle system is given by, once again I am repeating, the position vector of the center of mass of n particle system is given by, that is RCM is equal to M1 R1 plus M2 R2 plus and so on plus Mn Rn whole by M1 plus M2 plus and so on plus Mn. Therefore, RCM is equal to M1 R1 plus M2 R2 plus and so on plus Mn Rn whole by capital M. Consider this is equation number 1. Now differentiate differentiate the equation, differentiate the equation 1 on both sides. Once again, differentiate the equation 1 on both sides. Therefore, d by dt of RCM is equal to d by dt of M1 R1 plus M2 R2 plus and so on plus Mn Rn whole by capital M. Therefore, the rate of change of position is VCM is equal to 1 by capital M taken outside into M1 into dr1 by dt plus M2 into dr2 by dt plus and so on plus Mn into drn by dt. Therefore, what is the reason? The reason d by dt of RCM is equal to VCM. That is why here we wrote VCM. Therefore, VCM is equal to 1 by capital M into M1 into dr by dt is V1 plus M2 dr by dt is V2 plus and so on plus Mn into Vn. Therefore, VCM is equal to 1 by m into what is mass into velocity? Linear momentum P1 plus P2 plus and so on plus Pn. That is equal to 1 by m into P is VCM. Therefore, P is equal to, take m here, m into VCM. This is the required equation. My dear students, I hope you understood 3 questions whatever I taught in this video. Thank you.